Hello. So I have some friends and acquaintances that I've talked to and know about who have children or even themselves are finding themselves bored during this time of social distancing, and maybe even their kids are tinkering, taking apart VCRs and TVs, and they're very inquisitive, probably very brilliant, and they need something to do with those hands and that imagination. And I had an idea. I know sometimes I do some tinkering with some autonomous vehicles and toys and things like that. And so I wanted to make this video about something that might be appealing to them. And these kits are about 35 bucks on Amazon. So I think they're very appealing since they dabble into autonomous vehicles. It's very interesting to see what you can do with robotics and technology now for very low amount of money. And so I wanted to introduce you to that, and hopefully it helps you. So this is what it looks like. I bought a few of these for my engineering club so that students could assemble them. And I tried not to help them. This is one that I built right after I finished college. And the code I got online, kind of borrowed a couple people's code that I just kind of copied and pasted. So I'm not really a gifted programmer, but I know how to at least understand what the code does and adapt it if I have different hardware. But there's one. So this is the newer one. That one was actually pretty expensive to build. But this one, this is cheap. I think when I bought it, it was $35 on Amazon. I think the brand is UCTRONICS, whatever that means. All right, not sponsored, so I don't know anything about them. If they want to sponsor me, then awesome. But I'm not sponsored. But anyway, this is a pretty good deal. I think it was $35. The software you can just find online. I think I found it in a repository that had lots of programming for these types of things. So I turned it on, it runs the program. Once the program initializes, like now, it starts driving. And if there's an obstacle, it sends a feedback loop telling it to change direction, and then it scans with that ultrasonic sensor. So it sends high frequency sound out, somewhere around 30 to 40,000 hertz. And that packet of sound echoes back, and the software code is telling it to wait for an echo. And when it receives the echo response, it compares the echo response and decides once that echo comes back under a certain time, it infers that a distance has closed, like say a wall's in front of it. And so that code tells it to rotate. It tells the servos to cause the car to rotate, find another direction to go. So it's a very simple program. This isn't a learning program. However, you can build learning programs. This particular board, though, doesn't allow me to optimize software. And so I wasn't able to figure out a way to recompile my own code. And so that's something I'm working on, is seeing if there's a possibility to edit the firmware so that it will be able to compile its own code. Otherwise, that's one of the limits of Arduinos. This is an Arduino-based robot. I think with Raspberry Pis, it might be possible to integrate machine learning, but I'm still, looking into it, seeing if other people have found a way to do it. This is a wireless receiver and transmitter, so which allows wireless communication. So anyway, pretty simple, AA batteries. I know that's not renewable, but pretty fun experiment, especially for $35 if you're bored at home because of COVID. Something fun, educational, ultrasonic sensor. So if you're interested in bats, that's how bats see. That's how bats see, if you know what I mean. So lots of fun. Hope you enjoyed.